Concurrency conflicts happen when two or more users try and access the same resource concurrently. So we've got two clients which are trying to access the data on the server, and they might be trying to change one record simultaneously. For example, if we have a table here and two people are trying to access the name of the name of the student, as it happens, to different values, and they try to do that at the same time, what do we do to prevent that? So just to take this slowly, we will operate on, we simply do a simple change. Now we're well used to doing this. It's just using a bit of link and changing the first person's name to Bob, and then we save the changes, and that constitutes one transaction. So let's just slowly but surely we'll do that, and just ensure that the first record has been changed. So we'll take a look at our students table and view the data and see if it has been changed to Bob. So we'll view the data, and at the moment, yes, it has been. It's been refreshed, and normally we would just need to refresh to make sure it indeed is changed. So how can we simulate another client trying to change the data simultaneously? And the answer is we use this execute rule, which we've seen. It's a way of using SQL within our program, but as it happens, that seems to simulate another client who's accessing the server, and he's trying to set it to Joe, whereas we're trying to set it to Bob as well simultaneously. So we have a conflict. Incidentally, I'll just put this data back to where it is, so otherwise we won't get an error. We'll talk about that later. So we put that back and just refresh it to make sure we've got the original table. Now the other thing that we need to do is to, with our domain class with a student, we need to add this attribute, concurrency check. So that will actually check, therefore, the person field for concurrency. And to do that, we need to have this namespace introduced as well. So make sure you do that as well. Because if now we run our code, let's see what happens. Well, we get this error when we try to save the changes. We get an error, a concurrency conflict, and it gives us a bit of detail here to say that the first row we've tried to change it from two different clients, if you like. So let's just stop that code, and what we'll do is to introduce some try-catch error handling. So let's save we'll wrap our save changes with a bit of a try catch. So we've got our try, and then we'll add the catch as well. There's our corresponding catch. Now what we've got on here, we need to look at the value that we're trying to save originally, and then the value that the new client is trying to save onto the database simultaneously. And also make sure our table has got Rob in it or anything different from Bob, so that indeed we will get an error. So what we could do is put a breakpoint and run that after here perhaps, and then run that. So EX will contain the conflicted row, and there's only one, so entry 0 will indeed just be the first row which is in conflict. But that particular row has a current value, that is to say the value that we are trying to make it to, along with the other client is trying to change it using the value which has actually been saved so far to the database, and you'll see that that is indeed Jojo. So if you refresh the table, you'll find that it indeed is Jojo, which is the one which is placed in by the second client by default, if you like. So then the decision is, well, what do we do with these values? Which one do we want to have in there? So this is where we are able to make a decision. So what we could do is just take, say it's the first record, the current, put it equal to CV. In other words, put it equal to Bob. We could well leave it at Jojo, but we'll decide that we want. So we have control here. So let's just run that, and I'll go back and just make sure that we've got Rob in here as the first person, which is different from Jojo and Bob, and I'll need to just refresh that to make sure that that has been inserted. So if I run the whole thing now, we should find that Bob has been placed into the table. Let's just check that after it's finished running. We should find that Bob has indeed been inserted into the table. So just to summarize what we've done here, we've taken we're trying to insert a record, which we would usually do by doing a save changes. Then we've actually simulated another client by using this execute raw. Now, having done that, that will cause an error if we were to use save changes. So what we do is to wrap that in a try catch and then run it. Now, when we catch the error, you will find that we have a current value, which is the one that we are trying to save in, and the database value, which is the one which actually got saved by default. And then we decide what to do. Well, we say we'll put the table value equal to Bob in this case, and we could have left it at Jojo. One thing I'd like to check, I just want to see if I put a breakpoint here and then run it to that point. I want to know, to ensure that, to just see that the Jojo in fact has been inserted. So it will be inserted by default, if you like. So let's take a look at that. There's our table. So if we were to F11, just a single step past that line, execute raw SQL, then we'll notice that if we take a look at the table and I update that, then you can see that it indeed is Jojo at that stage. We could consider this to be what we call optimistic, in that it's the last successful insertion, which is the one that wins out. That's the meaning of optimistic concurrency, is when the last record wins out. It's if we have two competing, then it's the last one which will usually just as a matter of default. And that's the way entity framework works. We have optimistic concurrency. The alternative to optimistic concurrency is pessimistic, and that is to say when we apply locks on the individual records and then remove the locks when you're ready, and so on. So we've just had one example of handling concurrency. And the other way of providing for concurrency checking is using this timestamp attribute and so on, and we won't need this, and but that's another story, and you could well research that. But I've just shown you the most straightforward, simple way of dealing with concurrency.